Hello everyone, my name is Sonar. I'm a student of JK Business School pursuing PGTM, and this assignment is of business analytics based on a CART model. CART model. This is a diagram of CART model. Used to predict. Regression is used to predict for individual on the basis of information gained from a previous sample of similar individuals. For example, a person wants to do something saving for future, and then it will be based on his current values and the several past values. He uses a linear regression formula to predict his future savings. It may also be used in modeling the effect of dust in medicines or agriculture, responses of a customer to mail, and evaluate the risk that the client will not pay back the loan taken from a bank. What is CART? CART is Classification and Regression Tree model developed by Breman, Fidgerman, Olshin, Stone in the early 80s. Introduced a tree-based modeling into the statistical mainstream regress approach involving cross-validation to select the optimal tree. One of many tree-based modeling techniques, CART, the classic one, C5.0, software packages variants, etc. Philosophy behind the CART model. Data analysis can be done from a number of different viewpoints. Tree structure regression offers an interesting alternative for looking at a regression type problem. It has sometimes given the clues to data structure not apparent from a linear regression analysis. Look like any tool, as the greatest benefit lies in its intelligent and sensible application. When and what? If the dependent variable is categorical, CART produces a classification tree, whereas if the variable is continuous, it produces a regression tree. The supportive diagram to show the regression tree and the classification tree. The key idea behind this, take all your data, consider all possible values of all variables, select the variable values that produces the greatest separation in the target, and then send the data to the left, otherwise send the data point to the right. Now repeat the same process on these two nodes. You get a tree. Now further, we're going to evaluate the steps behind the CART generation. Step 1. Starting with the first variable, CART splits a variable at all of its possible split point. At each possible split point of the data variable, the sample split into two binary and child nodes. Cases with the yes responses to the question posed are sent to the left node, and the no responses are sent to the right node. It is possible to define this split based on a linear combination of variables. Step 2. The CART applies its goodness of a split criteria to each split point and evaluates the reduction in impurity or heterogeneity due to the split. This is based on the split creation. This works in the following fashion. Suppose the dependent variable is categorical, taking on the value of 1 and 2. The probability distribution of these variables at a given node are P1 by T and P2 by T, respectively. A major heterogeneity or impurity at node is a function of these probabilities. In the cases of categorical dependent, CART allows for a number of specification of this function. The objective is to maximize the reduction in the degree of heterogeneity. Going onwards. Step 3. It selects the best split on the variables as the split for which reduction is impurity. It is the highest as described in step 2. Steps 1 and 3 are repeated for each of the remaining variables at the root node. Card then ranks all the best splits on each variables according to the reduction in impurity achieved by each split. It selects the variables and its split point at the most reduced impurity of the root or parent node. Step 6 and 7 includes card then assigns classes to those nodes according to a rule that minimize misclassification cost. Although all classification tree are producers will generate some errors, there are algorithms within card designed to minimize these. Step 1 to 6 are repeatedly applied to each non-terminal child node at each of the successive stages. Step 8. Card continues the splitting process and build a large tree. The large tree can be achieved if the splitting process continues until every observation continues or a terminal node. Obviously, such a tree will have a large number of terminal nodes that are either pure or very small in content. Having generated a large tree, Card then preons the results using cross-validation and create a sequence of the nested tree. This also produces a cross-validation error rate, and from this optimal tree is selected. Further, we'll discuss some example. Goal: classify a record as is owner or not. Rule might be if lot size is greater than or less than 19 and if the income is greater than or less than 84.75, then classes R is equal to owner. Recursive partitioning: repeatedly split the records into two parts so as to achieve maximum homogeneity within a new parts. Pruning the tree: simply the tree by pruning first-fill branches to avoid overfitting. Impurity refers to obtain overall impurity measure weighted average of individual rectangles. At each successive stages, compare this measure across all the possible splits in all variables. Choose the split that reduces the impurity the most. Chosen split point become the nodes on the tree. First split the tree. This is the example of first split where card are divided. The card model is divided the tree branches into two splits. Tree after the three splits. Tree after all splits. So going forward, coming to the conclusion part, classification and regression tree are easily understandable and transparent method of predicting or classifying new records. A tree is a graphical representation of a set of rules. Trees must be prone to avoid overfitting of the training data. As trees do not make any assumption about the data structure, they usually require large samples. Thank you.